Hello friends, this is Dr. V. Sivanagaraju, Associate Professor in EC Department, IARE. Today we are going to discuss detection of AM waves. In my last videos, we discussed about modulation, how to modulate AM waves. In this session, we are going to discuss detection of AM waves by using square law and envelope detector. Okay, coming to the session. So first, what is demodulation? Demodulation or detection is the process of recovering the original message signal from the modulated wave at the receiver. Already we discussed the communication system. In the communication system, three main blocks are there. One is a transmitter, another one is a channel, and the last one is the receiver. In the transmitter, we are going to modulate the signal and send into the channel. Again, this signal is recovered at the receiver. So, where in the transmitter, modulation is done. Already we discussed what is modulation and why need the modulation. Okay. So, the demodulation is the inverse of the modulation process. Inverse process or reverse process of the modulation. We are extracting the original message signal from the modulated signal. So here we are using two varieties of detectors. One is a square law and another is a envelope detector. So first we are stepping into the square law detector. Here detector or demodulator we are using. It gives the same sense, no problem. So square law demodulator is used to demodulate low level AM signal. We are using two varieties. One is square law and one is the envelope. So in this picture, we can see the important blocks of that square law detector. One is the square law device and another one is a low pass filter, and finally one load register is used. So we are giving the input signal as a AM wave, that is amplitude modulated signal is going to apply to the square law device. Already it indicates the square law. Square law device means it is nothing but a diode. Already we discussed it in the square law modulator. Okay. So this is the picture what of the square law detector. It contains a square law device and low pass filter. So the standard form of AM wave is V1 of t AC of 1 plus Ka m of t cos 2 pi fct. This is the modulated signal or what you call AM wave, which is going to apply to the square law device. So we are getting that output of the square law device. What is V2 of t is equal to A1 V1 of t plus A2 V1 square of t. Here V1 of t is the input voltage and V2 of t is the output voltage, where A1 and A2 are constants. So this mathematical relationship of that square law device is already used in square law modulator, which is same. But here one main difference is we are using low pass filter at the output of that detector. That means it allows that low frequency signals only. Now we are going to substitute V1 of t in equation 1. So V2 of t is already know, it is A1 V1 of t plus A2 V1 square of t. So V1 of t is, AC of 1 plus Ka m of t cos 2 pi fct. So this is V1 of t. We are going to substitute in this V2 of t equation, which is A1 V1 of t plus A2 V1 square of t. So we are going to enlarge this equation. We get V2 of t. Why here we're having it is in the second part of this V2 of t is in the form of a plus b whole square, which is equal to a square plus 2ab plus b square. That is, we are going to simplify that equation. That output equation is going to simplify by using these trigonometric functions and algebraic formulas. So finally, you got this V2 of t, which is equal to A1 AC of 1 plus Ka m of t cos 2 pi fct plus A2 AC square cos square 2 pi fct of 1 plus Ka square m square of t plus 2 Ka m of t. So in the whole equation, what we get output is here it shows A2 AC square Ka m of t. A2 AC square Ka m of t we are taking. Why? The low pass filter, which filters the high frequency components, it allows only low pass filter. Here, what's our aim? Our aim is extraction of the original message signal. Here, m of t is the original message signal. Here, the A2 AC Ka. These are the constants of some amplitudes, so don't bother about that one. You get V0 of t is directly proportional to m of t. So we are extracted that m of t from the modulated signal. So this is the working function of this square law detector. And the next one is envelope detector. In the envelope detector, we're having this diode, and another one is a capacitor and a resistor we're having. So this envelope detector is a simple and highly effective device used to demodulate AM wave. So now the working operation of this envelope detector is taken as into two parts. One is the positive half cycle part and another is the negative cycle part. Negative half cycle. So during positive half cycle of the input signal, the diode is forward biased and the capacitor it charges up to the peak value of the input signal. Wherein the negative half cycle of the input signal, the diode is reverse biased and the capacitor discharges. Capacitor discharges. This capacitor discharges until up to the next positive half cycle. So here also you can see the low pass filter section. So the first half is a half wave rectifier section, so you're getting only half cycle. In the left hand side, you are giving this AM signal, amplitude modulated wave, to the left hand side of this circuit. On the right hand side, the output of the circuit is giving only positive half. Why? Here this diode works as a half wave rectifier. So that's why you're getting only half part of this total AM modulated wave. Now what are the advantages of this AM. Already we discussed about what is AM, what is time domain description and frequency domain description, and what are the modulators is going to generate AM wave. And now in this session we are going to discuss the detectors of this AM wave. Now, what are the advantages of AM wave? AM transmitters are less complex and AM receivers are simple and detection is easy. So these are the main advantages of AM. And disadvantage, here the power is wasted in the transmit signal, and AM needs larger bandwidth. So these are the disadvantages. So these disadvantages we come across in the next topic, that is a DSB-SC, double sideband suppressor carrier. Okay, thank you friends.
Like, share and subscribe. Hit the bell icon for more updates.